Hi there. Now in the last video, we have learned how recursion works internally, and we saw what's happening in the stack memory when we call a recursive method. And as you remember, in the introductory lecture of this section, we said that any problem that can be solved using recursion can be solved using iteration. Here, in this video, we will compare recursion versus iteration. As we said, all recursive algorithms can be implemented iteratively, although sometimes it's much more complex to do it. Let's look at the example which was implemented in both ways. Here, both methods calculate nth power of 2. As a parameter, both methods, as you can see, take n, which is an integer number. In the recursive function over here, we have an if condition here, which is a base condition to stop infinite loop. And then, if the condition is not satisfied, the function calls itself recursively and return a power of 2. In the iterative solution, we start by creating two variables, which is I and power. So, while I less than n, it multiplies power with 2, and in each iteration, I is increased by 1. So if you look at this piece of code carefully, we can see that recursion code is easy to write compared to iterative one. You might not notice it here in this code because it's very simple function. But there are many situations that converting a recursive function to an iterative function is extremely difficult. The second point here is a conditional statement decides the termination of recursion, while a control variable's value decides the termination of iteration statements. In this case, value of I decides the termination. Here in recursive function, infinite recursion can lead to system crash, whereas in iterative function, infinite iteration consumes CPU cycles. The next point is recursion repeatedly invokes the mechanism, consequently overhead of method calls. This can be expensive in both processor time and memory space, while iteration does not. Recursive algorithms can be very space inefficient. As we explained in previous video, each recursive call adds a new layer to the stack, which means that if your algorithm resources to the depth of n, it uses at least O(n) memory. For this reason, it's better to implement recursive algorithm iteratively. So the question is, does iteration work always better than recursion? The answer is no. Each of these codes has its own advantages. We use recursion especially in the cases we know that a problem can be divided in similar subproblems. And when we deal with data structures like trees and graphs, the usage of recursion is more efficient. This table describes the differences between recursion and iteration. Here you can see that the first point is space efficient. You can see here that the recursion is not space efficient, as we said that it takes O(n) time complexity, but on the other hand, iteration is memory efficient, no stack memory required in case of iteration. So we are not inserting any method to stack memory while we are doing iteration. The next point is time efficient. We can again see that recursion is not time efficient because recursion repeatedly invokes the mechanism, and this leads to the overhead of method calls. And this might be expensive in terms of processor time. And also, in case of recursion, system needs more time for pop and push elements to stack memory, which makes recursion less time efficient. But as we said, in case of iteration, we are not inserting any method to stack memory. That makes iteration time efficient. Then the next point is easy to code. As you see, recursion is very easy to code. Many complicated codes can be written in recursion very easily. But when it comes to iteration, it's very difficult to write some problems in iteration. That's why if we know that we can divide a problem into similar subproblems, it's advisable to use recursion. So that's all for the comparison of recursion versus iteration. Hopefully, you understand the main differences between them.